Okay, welcome to our video on factoring tougher quadratics. And what I mean by tougher is quadratics where the powers are higher than 2. So we have x to the fourth and x squared, and this seems a little bit more intimidating. But our basic strategy is to remember, well, what does the basic quadratic structure look like? Well, we had ax squared plus bx plus c. So essentially what we have, of course, is our c term, which is our constant. And then we have our b term, which is a coefficient, right? A number multiplied by a variable. And what's the variable? Well, it's x. And then we have another coefficient a, and another variable, but this is x squared. So one way to look at this is to say a quadratic is a polynomial where the highest power is 2. But another way of looking at it is you could say a quadratic has a constant, it has like 2 coefficients, a and b, and then it has a variable, and then that same variable doubled, or excuse me, squared, not doubled, but squared. And in a problem like this, where the power is higher than 4, we can rewrite it to look like this. So we have our constant, we have our variable. Now our variable is x squared. So this can be thought of as x squared squared. Just like here, it was x squared to get x squared. X was squared to get x squared. Now we're squaring x squared to get x to the fourth. So if we rewrite it as x squared squared minus 8x squared plus 16, we have a quadratic. So now we've rewritten this in quadratic form, which means we can think of this as a variable squared minus that same variable plus 16. And you could rewrite it. I mean, sometimes they say substitute, so represent x squared as a variable. Let's say r. So then you would see it as r squared minus 8r plus 16. And that really represents x squared squared minus 8x squared plus 16. But I prefer to keep it in this form here. Right? You could factor it out from there and then resubstitute in this at the end. But it's up to you. So here, how do we factor? Well, set up our brackets. Well, our variable is being squared, so we put x squared twice. And now we need to find factors that multiply to positive 16 but add up to negative 8. For me, that's going to be negative 4. Right? Because negative 4 times negative 4, that equals our c term of positive 16, but they add up to our b term of negative 8. And now we factored it out, but we can keep going here because you might recognize this. We have the difference of two squares, right? X squared can be thought of as a square with lengths of x on each side, and 4 can be thought of as a square with lengths of 2 on each side. So when we find the difference of two squares, right, this will be factored into x plus 2 times x minus 2, and so will this. So we can rewrite this as x plus 2 times x minus 2. Now you might want to leave it as this form, or you could write it as x minus 2 squared, and then x minus 2 and x minus 2, and then x plus 2 squared. It depends on what you're looking for here, but this will do as well. But these are essentially saying the same things. The point is, when you're factoring out with this kind of situation, look for the difference or sum of cubes or differences or sum of squares to see if you can keep factoring. That's a big hint. So that's one example. Let's look at one more in this video. And these might seem intimidating at first, but I think you'll get the hang of it. So next we have x to the sixth minus 4x cubed minus 5. So again, the form of the quadratic is that you have a times some variable squared plus b times some variable plus c. So the key is to look for a variable, see if you can square it and get this, and then you can think about whatever polynomial you're giving as if it were a quadratic, and you use those quadratics strategies to factor it out. And we can do that here because x cubed squared, right, x cubed squared equals x to the sixth. We can factor this out. First, rewrite it. So we have x cubed squared. That's this term. minus 4x cubed minus 5. So now we basically have a quadratic. It's hard to see because the x cubed is intimidating, but really you can think of this as, let's say, y squared minus 4y minus 5 if y equals, right, x cubed. So this is easier to see here, but then you have to always plug this value back in at the end, and that to me is difficult, so I leave it in this form. How do I factor it? Well, I have x cubed squared, so I need x cubed twice. And now I'm looking for factors of negative 5 that add up to negative 4. Oops. So what can I choose? Well, I know that to get negative 5, I can multiply out minus 5 and 1, right? Minus 5 times 1, that gives me negative 5. And if I add negative 5 and 1, that gives me negative 4. So that works. So I'm going to use these two factors. I have a negative 5 and a positive 1. And now essentially I'm done, except of course you want to look out for the sum or difference of cubes. This is not a difference of cubes because there's no whole number cubed that gives you 5, right? So instead we look at this one. 1 cubed is 1, so we have 1 cubed. And x cubed is also a cube. So we have x cubed plus 1 cubed. And then we still have x cubed minus 5. I'm rewriting this because now we can see that this is the sum of two cubes. If you remember the formula for sum of cubes, it's x cubed plus y cubed. Right? So basically two things cubed can be rewritten as x plus y times x minus xy plus y squared. Excuse me, x squared minus xy plus y squared. So, and there are many ways to remember this. You can test out these combinations, do the long multiplication, see it works. But here I'm just using this fact to keep going forward. So that being said, let's rewrite this term right here. So x plus 1, right? We need x plus y. So x plus 1 times what? Well, x squared minus x times 1 or x times y. So just 1x or x plus y squared, that's just 1 squared or 1. That times x cubed minus 5. And essentially here we're done because this quadratic factors of that multiply to positive 1 are 1 times 1 and negative 1 times negative 1, and they don't add to negative 1. So we can't factor this any further, and basically we're done. So we get x plus 1 times x squared minus x plus 1 times x cubed minus 5. And along the way you can re-multiply to see if this works. You can test it out. Multiply this by this. Does it bring you back to this? It will. Try it out. And if you're testing it here, multiply this by this. Make sure it gives you this quadratic right here. And in that way you can test it in pieces, even though it seems a little overwhelming. So hang in there. We're going to try a few more examples in the next video.